Have you all wondered how animators can bring lifelike moments to characters and objects, whether in films or in video games? Let's learn about the principles of physics to create realistic and believable moments in animated characters. This is Soumya from Sri Venkateswara College of Engineering, majoring in computer science and cybersecurity, here to explain about the amazing concept that is physics in animation. First, let's understand what is this term called animation. Animation is a method of photographing successive drawings, models, or even puppets to create an illusion of movement in a sequence. Because our eyes can only retain an image of approximately 1/16th of a second, when multiple images appear in a fast succession, our brain blends them into a single moving image. Animation is a process of displaying still images in a rapid sequence to create an illusion of moment. Now, let's look into the taxonomy of physics-based animation methods. At the highest level, the field of physics-based animation and simulation can roughly be subdivided into two large groups: kinematics and dynamics. Kinematics is study of motion without the consideration of mass and forces. Second, dynamics is the study of motion taking mass and forces into consideration. While kinematics and dynamics come into two flavors or subgroups, that is, inverse and forward. Inverse is the study of motion knowing the starting and the ending points, while forward is the study of motion solely given to the starting point. Multiple pictures forming an animation depend upon their frames, speed, and size and scale. Frames in an animation are individual images that are combined in a sequence to create an illusion of motion. The more the frames are per second, the smoother the animation looks. Frames per second means the speed of animation, which is measured in frames per second. A higher frame generally results in smoother and more realistic animations, but requires more computing power. The size and scale of characters play a central role in a story's plot. We often equate large characters with weight and strength to small characters with agility and speed. There is a reason for this. In real life, larger peoples and animals have a large capacity of strength, while smaller characters can move faster than their large counterparts. When designing characters, you can run into situations having to do with their size and scale. Here are four examples where you can encounter such situations. First, human or animal based characters that are much larger than we see in our everyday experience. For example, superheroes, Greek gods, and monsters. Second, human or animal based characters that are smaller than we normally notice, such as fairies and elves. Third, characters that need to be noticeably larger, smaller, older, heavier, lighter, or more energetic than other characters. Fourth, characters that are child versions of old characters. For example, animation featuring a mother and her kittens. If the kittens are created and animated with the same proportions and timing as the mother cat, they wouldn't look like the kittens. They'll just look like very small adult cats. In this slide, let's see through the proportion and scale used in an animation. Creating a larger or a smaller character is not just a matter of scaling everything about the character uniformly. To understand this, let's look into a simple cube. When you have to scale a cube, its volume changes much more dramatically than its surface area. Let us say an edge of a cube is 1 unit length. The area of one side of a cube is 1 square unit length and the volume of a cube is 1 cubed unit length. If you double the size of a cube along each dimension, its height increases by 2 times, its surface area increases by 4 times, and its volume increases by 8 times. While the area increases by squares as you scale the object, the volume increases by cubes. With this, I would like to conclude that By including physics principles, animators can bring lifelike movements and behaviors to characters and objects, making the animated world more believable and engaging for the audience. Whether in films or in video games or in simulations, physics plays a very fundamental role in creating captivating and immersive animations. Thank you all for watching my video. Please like, share and subscribe.